Welcome to the Linux track of the Oracle Technology Network Virtual Sysadmin Day. My name is Lenz Grimmer and I'm a member of the Oracle Linux product management team. In this session, I would like to give you a technical overview about Oracle Linux and the Unbreakable Enterprise kernel. I'll cover some of the unique features of Oracle Linux, and we will look at some additional benefits for system administrators when using Oracle Linux. This session also includes a short demo of ksplice, a technology to apply critical kernel updates to a running Linux system without rebooting. Just in case I'm talking about any future developments, my statements are intended for information purposes only, and you should not rely upon these in making any purchasing decisions. Oracle Linux is an enterprise Linux distribution, fully compatible to Red Hat Enterprise Linux. In contrast to other enterprise Linux distributions, it is freely available to download, use, and distribute. This also includes free patches and security updates. Oracle Linux is Oracle's base Linux development platform and the operating system that is used on our engineered systems like the Exadata or Exalogic machines. Oracle provides the same services that you would expect from any other Linux vendor. We have a dedicated development and QA team, as well as our own team of support engineers. Support for Oracle Linux is provided via the well-established infrastructure of My Oracle Support. If you're already an Oracle customer, you can simply submit Linux-related support inquiries using this familiar interface. We also work very closely with a large number of hardware and software vendors to ensure that Oracle Linux is supported and certified with and on their products. We also offer Linux training and certification, and you can hire our consultants to get started with Oracle Linux in your own environment. Oracle Linux is free, both as in free beer and free speech. You can download the ISO installation images from our website at no cost, and you are free to install it on all of your servers, regardless if they are used in production or just for development or QA purposes. You don't need to purchase a subscription in order to obtain security updates and bug fixes. This means you can keep all of your systems at the same patch level, and you are free to choose which of your servers you want to put under support and at which level. Moreover, the source code of the Unbreakable Enterprise kernel is available as a Git source code repository, similar to how the mainline Linux codebase is being developed and distributed. You can see each individual code commit and the related developer comments. The key component of Oracle Linux is the Unbreakable Enterprise kernel, which is a modern Linux kernel, derived from a recent version of mainline Linux. It is available for both Oracle Linux version 5 and 6. It brings the best innovations from upstream development into the data center by closely tracking the mainline kernel within a number of months, not years. This is a new development and distribution model for data center workloads. By following mainline Linux more closely, we will automatically inherit a large number of improvements and new features without having to backport these into a much older code base. This means fewer code changes, which results in better stability. What you get with the Unbreakable Enterprise kernel is a tested and improved version of Linux from the Enterprise Software Company. The Unbreakable Enterprise kernel has been hardened with Oracle workloads and on our engineered systems. The Red Hat compatible kernel is also included and supported. The pricing is the same regardless of the kernel you use. The Unbreakable Enterprise kernel provides a large number of new features and improvements. This slide attempts to highlight a few. I'll cover some of these in more details in the following slides. The Btrfs file system has been initially developed by Chris Mason at Oracle. It's a very modern file system which provides a number of interesting features that have not been available from any other Linux file system before. Due to its copy-on-write nature, it provides support for lightweight snapshots of individual files or entire directory structures. It also supports data integrity features like checksums and RAID functionality. A Btrfs file system can be resized on the fly, and you can increase the storage capacity by adding more disk drives. It also provides support for flash drives by optimizing its access patterns for this type of devices. Btrfs provides functionality like volume management that usually requires using additional storage management layers of the Linux kernel, like the logical volume manager or the kernel's built-in RAID functionality. There's a dedicated hands-on lab about Btrfs included in this event, so you can get some first-hand experience on working with the file system. Also included in the Unbreakable Enterprise kernel at no additional cost is the OCFS2 cluster file system. OCFS2 is a shared disk cluster file system. Multiple servers can concurrently access the same volume from a central storage location, like a SAN or an iSCSI target. It was designed for high I/O throughput for databases and full POSIX conformance. It provides classic file system features like POSIX ACLs, standard and extended file attributes, user and group quotas, as well as metadata checksums and error correction code. It has been developed by Oracle and was incorporated into the mainline Linux kernel with version 2.6.16. dtrace is a Solaris tool available since 2005, which was ported to the Oracle Linux kernel. It enables static tracing using instrumentation compiled into the kernel and applications. It also provides dynamic tracing by defining probe points live at runtime. Probes and actions at probe points are defined by scripts written in the D programming language. You can virtually trace anything with dtrace, from the kernel over system libraries up to the application level. All of this without any considerable performance impact. This makes dtrace the ideal choice to identify performance bottlenecks on production systems. Also included in the Unbreakable Enterprise kernel is the cgroups resource management framework. Control groups allow you to group processes together and to define rules and restrictions about how much resources these processes can use. For example, you can limit the amount of disk I/O, CPU cycles, or how much memory a certain process group may allocate. Control groups provide a very flexible and powerful way to ensure that service level agreements can be met. Based on cgroups, Linux containers take the idea of restricting and confining process groups one step further. Containers provide an isolated environment that includes a private PID space and network connectivity. This allows you to run individual applications in their own directory structure and environment, so they don't interfere with each other. This is a similar concept to Solaris zones or FreeBSD jails, and is a lightweight alternative to a full-blown virtualization technology. Other notable features of the Unbreakable Enterprise kernel that we've gained from mainline without having to backport them include support for transparent huge pages, a technology that reduces the overhead of managing large amounts of memory. When using huge pages, the Linux kernel manages main memory in chunks of 2 MB instead of the default 4 KB pages. This significantly reduces the size of the memory management structures required to keep track of all the available memory pages. The memory compaction feature nicely complements huge pages. It works similar to a defragmentation program and tries to merge small memory pages into larger blocks to reduce the management overhead. Traditionally, protecting the integrity of customers' data has been done with multiple discrete solutions, including error correction code, ECC, and cyclic redundancy checks, CRCs. However, there have been gaps across the I/O path from the operating system to the storage. The implementation of the T10PI standard ensures that data is validated as it moves through the data path, from the application to the HBA to storage, enabling seamless end-to-end data integrity. Oracle developers have been involved in implementing this standard on Linux for quite some time. The T10 Data Protection Standard provides interoperability between host controllers, external storage systems, and disk drives. End-to-end data protection is a new feature in SAS and fiber channel hard drives that extends error detection to cover the entire path from the computer system to the hard drive's media and back. Data protection information is appended to the data in the computer system. It stays with the data from the computer through fiber channel or SAS connections, through RAID controllers, and through drive electronics to the disk platter. When read, the same data protection information returns with the data to the computer system. The protection information is used to verify the correctness of the data at multiple points in the path. Oracle invests heavily in Linux and contributes to a number of Linux-related projects. We have our own team of dedicated kernel engineers that closely collaborate with the upstream maintainers. For some of these projects, Oracle employees actually are the upstream maintainers, collaborating openly in the Linux community. And just to emphasize what I mentioned already, the Unbreakable Enterprise kernel and all of the functionality I mentioned before is available as open source free of charge. We publish all of our patches and improvements upstream and push for inclusion in the mainline Linux kernel. The Unbreakable Linux Network, ULN, provides the web-based infrastructure to manage all of your subscribed systems and related customer support identifiers. You need to obtain an Oracle Linux support subscription to log in, for example if you want to access the additional software repositories we provide from there. However, a lot of information is freely available, including the documentation or more details about security-related updates. This information can be used by the YAM security plugin, which we'll cover in more detail in the package management hands-on lab later on. The pre-install RPM provides a very convenient solution to ease the installation of the Oracle database on Oracle Linux. By installing it on your Oracle Linux system, it will ensure that all of the prerequisites are met in order to satisfy the Oracle database installer. It also performs the necessary kernel configuration like the sysctl.conf file. This significantly reduces the time required to get up and running with the database. We are looking into providing additional pre-install RPMs for other Oracle products as well. The database Smart Flash Cache is a technology only available on Oracle Solaris and Oracle Linux. Available since Oracle 11 GR2, this feature improves performance by using solid-state disk drives as fast second-level database buffer caches. Data is cached on an SSD and can be accessed much faster than using traditional spinning hard disks. Also included in an Oracle Linux subscription are licenses for Oracle Enterprise Manager and Clusterware. Enterprise Manager helps you to deploy, manage, and monitor your Oracle Linux systems in great detail. It's a very powerful framework that can span your entire stack, from applications to disk. If you need to deploy services in a highly available fashion, you can use Oracle Clusterware, also known as Oracle Grid Infrastructure, to provide the foundation. It provides high availability using service failover functionality to another backup system, using floating virtual IP addresses to redirect service requests. Both this comprehensive management solution as well as the high availability functionality come at no additional cost. There is no need to purchase any separate add-on. Oracle Validated Configurations are blueprints of tested and validated Linux architectures, consisting of hardware, software, networking and storage components. These have been assembled by Oracle in collaboration with our partners and are proven to work. The descriptions of these validated configurations are available for free from our website, and they include detailed lists of all the components and versions used, as well as notes about any known issues or workarounds. They give you a fully tested and complete stack that you can immediately deploy in your own data center with confidence. Updating software on production servers using the traditional way can take a long time, especially since systems usually don't operate in a vacuum but have relations to other tiers. Shutting down the server usually means shutting down the application servers and databases first, then applying updaters, starting the database, starting the application servers, and performing sanity checks and so on. In case of urgent security issues, the system administrator needs to plan for lengthy discussions about scheduling with all affected parties, and also at the same time negotiate for the planned downtime. In fact, maybe several weeks later you may still don't have all of your systems updated, while a critical security vulnerability is out in the wild. This is where Ksplice enters the scene. Using Ksplice, you can apply critical fixes to the Linux kernel at runtime, without disrupting ongoing operations or having to negotiate any downtime. This is a feature unique to Oracle Linux. Updates can be applied on the live system while applications continue to run uninterrupted. Patches can also be removed again in case there are any unwanted side effects. Using the Ksplice technology also allows us to provide you with customized one-off diagnostic patches that help us to analyze problems on your production system. You apply the Ksplice patch to enable additional debugging functionality without disrupting the running services. Once we've collected the required data, the diagnostic patch can be pulled again without interfering with the ongoing operations and without ever rebooting the system. Ksplice operates by splitting up patches by functionality or scope, like a fix for a specific security vulnerability that is tracked by a CVE number. By using the source code and the resulting binaries as the input files, the Ksplice technology creates the zero downtime patch, which is then downloaded and applied on the client system. The patch process can be automated and scripted, or run in an interactive mode. We'll take a look at how Ksplice can be installed and how it works in the following short demo. In this short demo, I will walk you through the steps required to download and install Ksplice for rebootless kernel patching. This is an Oracle Linux 6.3 system running the Unbreakable Enterprise Kernel Release 2. I am currently running version 2.639-234.1. Let me first show you the traditional way of checking for available kernel updates. Utilizing the Yum security plugin, I can find out if there are any security relevant updates available for the kernel that I am running. I can see that there is a number of pending security issues, which are resolved in version 2639-317.2 of the kernel. Using Yum, I can now update the kernel to this version to obtain the fixes for the security issues mentioned. Yum will first download the updated kernel RPM, including its dependencies, and will then install the packages. This process takes quite some time. As you can see, I am still running the previous kernel version after the Yum update. Installing the kernel version alone is not sufficient to activate the fixes. I would have to perform a full reboot with all the potential disruptive consequences this might have in my production environment. I'm going to skip this step at this time to show you an alternative. Enter Ksplice zero downtime updates. Before I can start using it, I need to download a small shell script, which will perform the installation of Ksplice on this system for me. It requires an access key, which I get from the Unbreakable Linux network if I have a valid Oracle Linux subscription. Running the shell script by passing the Ksplice access key as an argument, it will subscribe my system to a new Yum repository and download and install a few additional packages. After the installation, Ksplice will query the Ksplice server and print out a list of all available rebootless updates. The Ksplice command line utilities all start with uptrack. Uptrack upgrade will list all the patches it will install once more and ask for my confirmation. After selecting yes here, the tool proceeds with applying the security patches on the live system. Running applications are completely unaware of this and remain unaffected. The command uptrack show will list all the patches I have currently installed on my system. It will also tell me the effective kernel version, which now resembles the one I would have achieved by rebooting after installing the appropriate kernel RPM. Note that the default kernel version printed by uname has not changed. Once patches have been installed, I can use uptrack uname to identify the kernel version that I am at from a patch level point of view. I can also revert individual patches using uptrack remove, in case I observe an unwanted side effect. Again, this can be done at runtime without the need for a reboot. This particular feature is quite useful as it allows us to use ksplice for other purposes, like installing diagnostic patches, for example. I hope this demo gave you an impression on how easy it is to work with ksplice, and you see the benefit of using this technology to complement the current RPM update practice, which can of course take place in parallel. There are some common questions that come up with ksplice, so let's respond to those since you might be wondering about these as well. How does ksplice interact with my third-party kernel modules like EMC PowerPath? The answer is pretty well. We guarantee that the kernel ABI remains unchanged as part of our patching process, so other modules aren't even aware that we're there, and they keep running as usual. That said, we don't update these third-party modules. We can only update the Oracle Linux kernel and Oracle Linux modules. In other words, the things we provide you and the things we have source code for. User space applications. As we mentioned earlier, ksplice only updates the kernel and only does so in memory, so you need to continue using yum to update your applications on disk. In fact, you also need to continue using yum to update your kernel on disk if you want to do that. So what happens when you reboot? If you've installed a new kernel image on disk and you reboot into it, ksplice notices this and will start to look for updates for that kernel instead. If you reboot into the same kernel, ksplice will reapply any updates you had installed when you rebooted. So you're in the exact same state post-reboot as you were pre-reboot. For existing Red Hat customers or CentOS users, switching to Oracle Linux support needs only minutes, not hours. You don't need to reinstall any software. Your applications remain untouched. The process is very simple and outlined on the web page mentioned on this slide. All you need is a ULN account, which will be available once you purchased an Oracle Linux support subscription. Download the registration program and then download the updates via UpToDate or yum. Last but not least, I'd like to introduce the 3 hands-on labs of this virtual Sysadmin day that will follow this session in the Linux track. In order to follow the lab exercises, please make sure that you have prepared your system and you are meeting the prerequisites outlined in the event pages. In short, you should have Oracle VM VirtualBox up and running. The Oracle Linux appliance should be imported and booted from the initial snapshot state. I recommend to revert back to the original state before starting any new hands-on lab session, just to make sure that any previous modifications don't have any unwanted side effects on the outcome of the next exercises. You should also have a copy of the hands-on lab exercises handy, either in the form of a browser window or as a PDF. This depends on how the lab material has been provided to you. In the Linux track, you will now be able to get some practice on the following topics. Package management. In this lab session, you will use the package management on Oracle Linux using RPM and yum. Some of the tasks that you will experience include listing installed packages, obtaining additional information about packages, searching for packages and installing or updating them, as well as verifying package integrity and removing software. We'll also review Linux services and run levels, how to start and stop them, checking the status of a particular service, and enabling a service to be started automatically at system boot. In the storage management hands-on lab session, you will learn more about storage management with LVM2, the Linux Logical Volume Manager. preparing block devices, creating physical and logical volumes, creating file systems on top of logical volumes, and resizing file systems dynamically. You will also practice setting up software RAID devices and configuring encrypted block devices. In the last session, we'll take a look at working with the Btrfs file system. We'll introduce you to the Btrfs file system, and you'll be able to create and mount a Btrfs volume and learn to set up a mirrored or striped file system across multiple block devices. You'll also learn how to add and remove block devices and how to create file system snapshots. I hope that you will enjoy these lab exercises. If you're working on these during the live event, feel free to get in touch with us via chat in case you have any questions or trouble. For additional information and resources, you can also get in touch with us at oracle.com/linux and join our social media sites to get day-to-day updates. Thank you for listening and have fun!